Welcome those who are already with us. It looks like we have a few more in the waiting room. I'm going to keep hitting admit and admit all as they come in. My name is Nathan Lowry. I am accompanied with Ron Burns. We are both members of the GIS Colorado Communications Committee and have enjoyed kicking off the Geo-Ruckus last month. We had Dr. Joseph Kursky. Today we have Mr. Brady Hustad of Argis. And as I continue to approve people coming in, hopefully I can give enough rattle so that nobody's missing anything at the top of the hour here. I'll be sharing a few introductory slides, and then Mr. Husted will be speaking for the balance of the hour. Hopefully we'll have a little bit of a chance for questions and answers at the end. And then at the last 5 minutes or so, Ron will um, give us what's going to happen next month, and help us to understand what those opportunities will be for Geo-Ruckus, and then ongoing for GIS Colorado, the next quarterly meeting, and upcoming GIS Day activities. So I hope you can stay tuned and listen to those things. Let's see. I'm admitting Brady Hustad again.
Not sure
Um,
who that
yeah, yeah.
I'm multiplying and I didn't even know it.
Yeah, I thought about doing the same thing, having myself in there twice or three times. Um, does get a bit tricky to remember, but this meeting is being recorded, so it can be shared with others after the fact. Not everybody can join us on a Thursday evening at 6 p.m. Mountain Time, but we're glad for those who can and are here live. Welcome, uh, Jason, Nate, Yulian, Al, and anyone else who happens to come in. And if you want to add questions and comments in the chat, you're more than welcome to do that as we go along. Um, Forgive the heading there being rolling over, but I do want to introduce Mr. Brady Hustad, the founder and CEO of Argis, is what that says behind his picture there. Brady Hustad is the CEO of Argis Solutions, which he founded in 2016 as the first augmented reality GIS company in the United States, whose mission is to provide GIS professional services that are client-focused and practical. For over 25 years, Brady has developed, architected, and led development teams in the geospatial industry with a focus on custom development, research, and design. Recognized for top technical sales, his work has earned two Esri Partner Innovation Awards, the Infrastructure Management and GIS Award for Innovation in 1920 or in 2022, and the ArcGIS Platform for Innovation Award in 2016 for groundbreaking integration of augmented reality with Esri ArcGIS software. He has multiple published articles, papers, and has participated in numerous interviews covering advanced and visionary technical concepts in GIS and computer vision. As of June 20th, 2023, Brady Hustad is serving a 3-year term on Esri's Partner Advisory Council. He holds a patent for integrated augmented reality with ArcGIS software and a patent pending for computer vision and machine learning in the medical industry. Compelled by the mantra, show me um, what I can't see. Mr. Husted and the Argis team have developed the Argis Lens, Argis Solutions augmented reality mobile application, a tool for field work that displays ArcGIS data as augmented reality visualizations. The technology of the lens has expanded into Z-Focus, an augmented reality extension for ArcGIS Field Maps. Z-Focus offers an augmented reality field experience with advanced Esri integration in an affordable, easy-to-use application. Brady Hustad's support for Colorado local government through ArcGIS's GIS Managed Services Consulting has had a considerable positive impact on the implementation and attainment of goals for municipal, county, and regional governments in Colorado. Particularly the interactive Felch quarry map for the Royal Gorge Museum and History Center, based on an original source map created by quarry property owner Marshall Feld and paleontologist Ken Carpenter in 1994, was profiled recently in ArcGIS, in ArcNews in the spring of 2024. Brady Hustad strives to constantly learn and grow to put himself in the arena. His objective is to move the needle. Mr. Hustad, would you like to?
Oh,
share now. I'm very excited about this Z Focus and augmented reality for ArcGIS Field Maps X, Y, and Z.
Awesome. Yeah. So let me share. Well, with that introduction, I don't know if I ever need to say another thing about myself again. It's embarrassing. Hey, y'all, can you all see my screen?
We can.
Awesome. Awesome. Well, you guys now know I am Brady Hustad and I am the founder of Argus. And what I was asked to talk about today was kind of the story of innovation, the story of how we got from, well, point zero to today, and what has augmented reality looked like, and what does it look like today? How did it get there? All the different steps. And so I thought I'd start at the beginning. And so, as I kind of mentioned, Argus is 8.5 years old now, and it actually starts about a few years before that, actually, almost 12 years ago now. So before I founded Argus, I worked at a company. It was called, well, a bunch of names because once you start getting bought by private equity, names can become fluid. It was started as Idea and ended up as a Stadia. And in that, I was the national director of development. So I had about 100 developers working for me. But the kind of intriguing part was I had an R&D practice, and I ran that R&D practice to try to kind of bring innovation or bring new ideas or bring new reasons to work with our organization. It was during that time that I went to a small little show. If you ever wanted to be kind of mind boggled by the size of technology, go to something like the Qualcomm show. And so I went to the Qualcomm Uplink conference back in 2013. And at this, there was this really nascent little tool. There was a side thing. I mean, they're announcing they just sold their billionth chip. Yeah, billion chip. Um, Pretty intense. But on the side, in a little box in the corner, they had this thing called Vuforia. And Vuforia was an early augmented reality SDK for the Unity gaming engine. And actually, this is a screen from that show of what they were trying to attempt. And they were looking at, and the big demo they had is a little car that sat there. And if you looked at the car with your technology, their technology and their kind of modified tablet, you could change the diagram. You could put new wheels on it. You could hot rod it up a little bit, right? That's what they're doing. And so I was able to corner these engineers and I asked them a bunch of questions because this really intrigued me. And I was like, well, what are you going to do about outside? And they looked at me aghast, like I had said the a swear word. And they were like, outside? We're never going outside. We could possibly be feet off. And I sat there and went, huh, I don't know any GIS data that isn't feet off. I think I have an opportunity here. And so we began looking into the concept of augmented reality for GIS or AR plus GIS. That was kind of the day of the inception of the idea. Now, the moment that this kind of happened, I started thinking about various why. Why would you want augmented reality? And I immediately thought, because we're always laying data, and then there's always this kind of breakdown. You'd do this really beautiful GIS work, you'd lay it on your maps, you do all this type of stuff, and then you'd go and you'd give it to the field ops, and you'd find out they're still using map books that they've actually penciled up that they've been using for 12 years because the GIS data they tell you is just not useful. There's no translation, it breaks down, it becomes unuseful in its form or faction or function as you get into the field. Yet I think there's so many things that could be of value if you could find a better way to visualize or a better way to see it in the field. Things like boundaries and pipelines, buried utilities, water systems. I mean, anything that's hidden or can be explained with additional visualization better really becomes impressive. One of the first ideas that we came up with was ROI or right of ways. Sorry, RWs, right of ways, where you're doing encroachments and things like this. Where I mean, many times they're sending out like surveyors and expensive personnel to do these right of way surveys to figure out what's encroaching, what isn't. Yet, if you could actually put the actual boundaries of that right of way into the real world and just take a picture of it and say, "Hey, is this encroaching?" Kind of simplifies the whole process. And so that weekend, and you'll laugh, that weekend, I went home and I built the first version of what we called the lens. Yeah, it took me a weekend. It was amazing. It worked if I rubbed my belly, stood on one foot, and chanted the ABCs backwards, but it did show GIS data in the field. That, of course, was trashed and thrown out many, many times in those first few years as we tried to figure out how to make things work. But this is actually a picture from when that was earliest systems. This is probably about a year after that, probably early 2014. And so this is what it looked like. Um, this was built from scratch in Unity, which is a gaming engine. And the reason it was built from scratch in Unity is because there was no SDKs. There was no support. Apple had nothing. It barely had sensors. Android had nothing. It barely had sensors. There was no frameworks. There was Vuforia was too limited. Vuforia really didn't do anything except on a tabletop. If you tried to take it off the tabletop, it just broke. So we built this thing, and after that weekend, I went and proposed it to a Stadia, and they funded it. And they gave me about just shy of $1 million to build the first version of this. Over the next 2 years, we kind of hacked at this and tried to kind of build it up. I had a team of about 5 people. We had a marketing team. That's when we started the patent. We actually filed for the patent in 2014 and were awarded it in 2018, um, which actually put us ahead of almost of all patents. There's theoretically Apple might have gotten one in before me. That's the only people. Anyways, uh, we had a lot of fun with that, and it was pretty cool. And it was about that time in 2016 the private equity firms bought a Stadia, and they were not interested in venture, and they considered the R&D practice venture, and I offered to buy it. And that's when I bought it, and that's when I founded Argis, AR plus GIS. And so that's kind of the history. That's where we started. And that's where it began. That's what the concept of the idea that now is still becoming, more and more of a refined and a more usable idea to these days. Now, in those early days, the challenges of AR were pretty vast. In a lot of ways, they're the biggest one is what you see on the screen. I love Don't get me wrong, I love the Marvel movies. I love Iron Man. It's amazing. But I also kind of cursed him a lot at this time because Iron Man came out and there's like these amazing graphics and he's like touching the world and everything's happening and he could get in his suit and he could look at the world and rockets can hit the exact targets and miss innocents and it's just this amazing, beautiful thing. But the reality what we were able to produce for field augmented reality was a lot closer to what's on the right, which did not have rocket directions, did not have automatic sensing, didn't have beautiful suits that you could just kind of touch and manipulate with like mental commands and all of these things. In fact, the beginnings of just even verbal commands, there was no real natural language modeling. It was very nascent. Verbal commands were just beginning, touch gestures, things like this were barely working. And so it was not the same. And that was the biggest thing is people had this expectation. It created this expectation of what they wanted, but a reality of what the technology could provide didn't actually match. In fact, there was a pretty big gulf in between them. Um, and 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 so we had to overcome that. We started to attempt to overcome that. And then we spent the next 8 years trying, right? Since then, there's a lot of things that did happen, right? So you go from that beginning, that nascent, that idea, and over the years and what has happened? Well, a lot of things have happened. The biggest is the hardware has improved. Many of you might have iPads that have a LiDAR built into them. Just go back to your 10-year ago or 12-year ago self and say, oh yeah, in a moment, all of our mobile devices are just going to have a LiDAR built into them. Whoa. That was kind of a big deal when it came out. And it's a big deal when it comes to the conceptual idea of sensing, because when you're in augmented reality, you have to know all of the factors of where your device is. That helps. The sensors have improved. The primary sensor that augmented reality uses is usually called an IMU or an inertial measurement unit. It's either 6-axis or 9-axis. 6-axis is if it's just an accelerometer and a gyroscope, 9 if it's also got a magnetometer and an electronic compass. And by using these, you can figure out where you are, how you're moving, what direction you're facing, where your camera's looking, and then be able to build the code that says what would be out there if they knew your GIS data. Those have gotten a bunch better. The weakest is still the magnetometer, but they're, exponential factors better since then. The operating software has gotten better. There's LiDAR, there's SLAM technology built into the functionality of it. And on top of that, Google, Apple, even Esri's now in the game with their Unity SDK engine. Unity itself with its AR framework have built SDKs and frameworks that use this technology that's built into their hardware, that's built into their OS, and allows you to access that and use it. And so halfway through our process, we started getting to use all the doctorates that Apple and Google have bought and use what they've learned to make our systems better. But probably the most important thing that changed is the expectation and the market's readiness for augmented reality. People have seen it now. They've started seeing it in the world. They've seen demos of it. They've seen our technology. Probably some people on this call have seen me demonstrate this at shows, at events, maybe directly to your organization. The reality of what is happening has started becoming something that people can see and accept. And also, they've been able to take the time to understand it and start seeing that there could be value in this in their organizations or in their starting to see use cases, starting to see methods of it being functional and not just kind of a science fiction concept from a movie. And the final thing is data accuracy. Data accuracy has been going up in leaps and bounds with the ideas that needing more accurate data for things like digital twins or being able to, for drones and using them to collect data, but also using the data to fly them, all these types of things has really put a pressure on us to improve our data. And we have across the board, many people, I used to say 12 years ago, I'd say no GIS data barely was 2 meter accurate, less 2 feet. Yet nowadays there's much data that, at least we brag. Now I'm gonna get on this. We brag it's inch accuracy. And we go through these things and say, we've really collected some amazing data. And well, maybe I might take exception that all of our data is actually that accurate all the time, especially when you bring it to the visceral reality of putting it on the world. The quality of data increasing and the ability to afford high accuracy, high quality GNSS devices has really opened up the other opportunities for this. And we're going to talk. And I'm going to stop. So I've gone through this. I've stepped from the beginning, where we started, why we did this, that idea, the concept, and then into the future with how the hardware and the software has helped us become better and better at this, and even the market readiness of those that are listening to me right now for the concept of augmented reality, virtual reality, the extended realities. But one of the biggest challenges every time I go into an organization is accuracy. They pull up augmented reality, they put it on the real world, like, whoa, it's not in the right place. And I'm like, yeah, it's not in the right place. And they're like, oh, can't use that. It's not in the right place. I'm like, yeah, but that's for the first time in your life, you're seeing your data actually as it relates to the real world. And they're like, yeah, but it's not in the right place. I'm like, yeah, sorry, it isn't. In the GS world, we are so more accurate than we used to be, like way more accurate. And I think all of us can agree with that. But the concept of our accuracy still has limits. We still have things that cause our view of our data to be inaccurate and also to possibly lie to us about the accuracy of our data. One of the first things is age. Now, actually, I saw that we're going to have somebody speaking, I think Jason Dutcher, that is part of the Geodetic, which is an amazing thing because they talk about this and the conception. We're better at this again, too. This is better than it was 10 years ago as well. But, as your data ages, the earth around it moves and your data becomes less accurate. Is it just by centimeters per year? Is it by inches per year, feet? All of these things affect your data. Additionally, things that affect your data is the quality and the transformation of your data in its projections across the board. And if you've ever transformed it, how you transformed it, did the transformation actually have a true mathematical model, or is it an estimation model? These transformations and the picking of your datums and your projections can insert feet to like 15 meters of error in some cases. It can be very challenging to hold that down. And you may not even know there. In fact, people might have lied to you and said, oh, that's a no loss transformation. But it might still be a loss transformation. If there's nothing else, the machine that you use to do it rounded the significant digits, and significant digits when you're using many coordinate systems in GIS actually are feet of accuracy. So there's a lot of things in get there. Now, again, they're coming up with they're trying to work with a national system reference system, national spatial reference system that is going to help make this and focus on the GNSS and geoids to help make it more accurate. And these are just incredible good things for us. But we really have to think about what is our accuracy. But a more important question, after all that, I've debunked it, that maybe your data is not as accurate as it could be. And maybe it is. Maybe you did all of that stuff right. And maybe you don't know, right? But the reality is, and the challenging part of the question is what level of accuracy do you really need to create value in the field? Sometimes you might need to be super accurate, but sometimes maybe within a meter or two is just fine. The average locate is no more accurate than plus or minus 18 inches. That's actually by law, the standard, and the magnetic wand cannot be more accurate than that. So when people paint your ground and people are digging off of it, that's basically a meter. That's where they are. That's where they're starting. Okay. What do you need to make value in a use case that creates a difference that saves effort, efficiency, danger, and failures in the field? What is the accuracy that's needed for that? And that's a question that we all have to ask for ourselves when we start looking at the use cases, when we start bringing our data. Because one of the other things that goes with this is, did you know that your base map can be inaccurate? After it's been out there for a while, your data may be really great on a base map, but then you put it on the real world, but the base map itself doesn't line up with the real world any longer because it has data, has age, or it has something going on with that. So a lot of stuff on that. So what are the factors that go with this? What creates or what helps or what parts of accuracy interact with AR? Well, it's mostly with the GNSS. So if you think about it, if you collect data and say you really did, you got it and it's sub 6 inch, it really is rock solid. So you're at 6 inches of accuracy. You pull that data up. Maybe it's not even transformed. Maybe it is, but say then once it's done, it's in the system and you're pulling it out of it, you're going to say it's a foot accurate. Okay, that's fine. So you've lost a little bit there, but you're still really, really close. Now, when it comes down to the mobile device, to connect that data to the mobile device, you have to know how accurate your position is. And that, again, is decided by the GNSS of either that device or if you're using an external GNSS. So are you a cellular-enabled device or is it Wi-Fi only? Depending on if it's an Apple, it doesn't have an actual GNSS in it if it's Wi-Fi only. Are you pairing with the GNSS? The average mobile device, like my Android phone here, is really just a 2.5 meter GNSS. So that's as best as you can get. And other things, well, that shouldn't say isn't, it should is used. Anyways, tree cover, close proximity to concrete buildings, all of these things affect it. Magnetic device cover. Do you know that the early iPads came out with the device? Do you remember the flip things that came out? Yeah, that had a magnet in it. That wreaked havoc on the internal compass. Also, if you're standing near like railroad tracks, which are giant electromagnets, many things can affect your accuracy and then minimal satellite coverage caused by many of those things that are blocked. You're in a canyon, you just can't get that many satellites. All of these things affect the accuracy and make it so it's a more complex solution to go through than to just show it and it's there, right? And so that's been a challenge for us to work through. And now I would like to say that with all of that, with the new data and the things that are going on, we are much more accurate. And also, we have found that many of the use cases, if you're within a meter or two, when you're doing situational awareness, if you're just doing a review of a field, if you're doing a right-of-way assessment and your intern's out there and they're just snapping pictures, if it's within 2 or 3 feet, that's really all you could ask for anyways, because anything that close, you're probably gonna have to send somebody out to do permitting or fines or whatever that goes with that. And so there's many things where that accuracy level starts becoming very valuable for you still without it being sub-inch. But we have seen sub-inch, and actually we're actually using that, the Arrow Gold right there. We've been able to collect data and then visualize it when it's less than 6 inches off afterwards. And it's pretty awesome because we collect it and show it right away, and it's a pretty amazing thing. And so with that, all of this stuff and this big kind of concept of accuracy and kind of how this can be a stumbling block for all of us, what are we doing today? Like after all of this time, I've thought about augmented reality for a few years at this point. And, we might have learned some lessons, some failures, some successes, some use cases that have actually rolled out and have been successful, some that have not. It leads us to where AR is today. So you ask, why? Why did we create Z Focus, our latest iteration that's going on right now? And it's because of these things. We've used what we've learned and we use that to guide us through to the next stages of AR plus GIS. And it really boils down to these three things. And for those of you, if you have some people on this call that are not Esri users, it's okay. There can be other, it can work with other technologies, but there's a reality. Esri is the gorilla of GIS. And so most people are on an Esri platform of some sort. Their data is in an Esri standard. And so if we and the key of adoption, especially in field adoption, if you've tried to roll out any type of technology to a field organization, it can be very challenging, right? Their day-to-day job isn't to play with computers, can play with iPads. It's to get the work done, to turn valves, to fix damage, to assess things, to dig trenches, to lay wire, to so many other things, and very few of them have to play with computer as part of them, right? And so adoption can be incredibly difficult. In fact, change in any way is one of the hardest things for humans to do. We don't like it. The general rule in the world of VC is you have to bring 10 times the value, 10 times the value to get them to consider change. So that's 10x. You have to have pennies on the dollar for what you're charging for the value that it brings them to even start considering changing. Okay. And so we boil this down to three things. And one of the first things is people are comfortable with Esri. Generally, large amount of the people out there, you use it, you have it, you've started adopting some level of Esri standard field maps, collector before that, something that's gone with this. And so we've added this into it. So we're just actually an extension to a technology that's starting to be used and adopted in the field already. The first thing. Second is it has to be easy to use. If you're looking at a classic workflow, and we're going to look at the workflow that this goes in, if that workflow takes 10 or 15 minutes, it's not going to happen, right? That's not their job. They don't want to do it. And so it has to be easy to use. You have to be able to go through the whole workflow and build this up in a way that can be done in about a minute, maybe two. And if it brings value in a couple minutes, they might use it. And finally, is it has to be affordable. It has to be pennies on the ROI dollar, right? It has to be able to get to fit in there. And also, if you're extending another technology like the Esri technology, it can't cost more than the Esri technology. It has to be less. And so if you're looking at a mobile worker cost or something like this from Esri, that puts parameters on what is acceptable for field costs in the field for technology. And so the primary value that we bring with this is that gap we talked about early, the communication between field to office, office to field. This is here to help bridge that gap. We're going to show a video so you can kind of see how it works. But one great story that we have for this is we're going through this as demoing it. And this, we're stepping through the, in the normal long years process of purchase it takes to get things like this going in the field or in government. But we're talking to an organization and I'm demonstrating. I say, here it is. They're in the field. They're starting to do it. They're going to do a situational awareness. They pull it up. They see it in field maps. They click this button. It brings it over into augmented reality. And they see that and they see their pipe going. And then they see that they can't do their job and they take a picture of it and immediately brings up a report that they email back to the office to tell people about this so that you now know why they didn't do what they did. And he says, and that's when I saved two rolls of my truck, or a roll of my truck. Sorry, I said two. And I said, what? And he says, so right now I go out there, they do that. There's a concrete slab over the wires that they're supposed to be digging up. They come back the later that day. They tell me they couldn't do the job. It was blocked. I send a supervisor out there. The supervisor now takes pictures of it, figures out what it is, comes back. And then the third time somebody goes out there, actually does the repair, fixes the slab, does all the things they have to do. 3 truck rolls. You just saved me 1. I'm only doing 2. Saves me 33% of my time immediately. That is communication from the office to the field to the office that makes sense and is immediately and viscerally real. Hey, my pipe goes under this retaining wall that now exists. My pipe goes under this flooding. There is something. Or 95% of the time, it's just a picture that says, everything went great. I did it. Woo, done. So all of these things, and that's what we're trying to accomplish with this and with this for you. So here's a video of it working, just so you can kind of see what AR looks like today. It's always fun to have a video that's like static because you can't see as the person moves. You can see as they try to type that kind of jitters the screen a little bit. But basically they typed in, they looked at their map, they hit the map, they go and there's the data. And at this point, you could start your report. You could take pictures, you could start your report, you could complete everything. That's how long it takes. You can tap on the data, you can get all the attribution, any information you need about it, as it just does. And that's how simple it is. And that's the goal. That's what we were trying to accomplish. We wanted it to be that fast. So you can just visualize, so you can see your data, you can connect to the world, extend your understanding. You can turn layers on and off. You can run it just like you do your map. And that's also purposeful. It also uses symbology of your map. So you're used to seeing your data in this format. You're used to seeing what it is. These are the colors from that symbology. I have to figure out how to get past the video. So how AR field work supports. It's the things that are being used today. So if you're thinking about this, or it's something that's rattling around your brain, thus you're on this call, what are going on right now? What are people deciding to do with this? Well, field reconnaissance, right? You just go out, you kind of check it out. Hey, I think we're gonna be doing some work in this, but this is what the design looks like. How does it impact? What does it look like? Does it make sense? Does it basically make sense in the field? Oh, it doesn't. There's a something here, or it does. This generally makes sense. Or these are how many people I'm going to have to talk to. Or if I have to talk to them because I'm going to be going over their land, how can I show them what I'm going to be putting under the ground? Well, this is pretty quick, right? Rapid asset and boundary location, right of ways, just understanding where are my boundaries, where am I supposed to be, where am I not supposed to be, what isn't supposed to be where it is, and all that type of stuff. Safety issues, discrepancies, site problems. Again, 95% of the time, field crews know all this stuff. They're not going to do anything but helps look, if nothing else, document why a job can't be done or why a job was dangerous. And sometimes we all do have strikes. We all have those situations occur. It can help stop that, right? The stakeholder communication and collaboration. How do I get buy-in? How do I show people where the things are? How do I connect them to the data in a way that everybody understands, from commissioner to field operations and back up through my organization? And of course, quality assurance. It might frighten you if you're on the GIS side of this, but empowering your field to say, this is why I don't like your data. This is why I don't use it, because click, it's over here and I'm over here, right? Being able to show you that and allow you to start understanding how you can help do quality assurance on your data, get it better, get it more accurate, and get it more usable in the field is incredibly powerful. An average workflow right now is very similar to this. Quite simple. We want it to be simple. That's why we built it this way. You can log into Field Maps, you pick a data, you click a button in there that links to zFocus. It goes over there. You do a worksite walkthrough, you take a picture or two. Is there any discrepancy? Is there a reason I can't do it? If not, that's great. If so, document. You take the photo, you click report, it sends it to the your supervisor, and you're done. It literally can be done in less than a minute. And that's how it's generally being used. I'm hoping, as I tell other people of this, as we're just launching this, it's in beta right now. So these are beta stories right now. We're launching it probably this month, maybe next, as we are, because we are in the approval process in the store, which can take time, as we all know. Or I guess anybody that builds mobile apps knows. Um, but then if you're looking at these things to consider with your data, so you said, hey, that'd be kind of cool. I'd love to join your beta, or I'd like to get this when you bring it out. Um, great. What should you consider? The first things you should think about are, what are your most important assets? What are you really going to try to protect? What do you care about? What do you need to show? What do you need to track? Can I do this in a way that affects and brings the most value to my field operations? Are there things that are known points? And a known point is kind of a simple process. It's a conceptual idea of laying your data and connecting it to um, something that you can visibly see with your eyes, a valve cover, a meter box, a flagpole. I mean, it could be almost anything. And by connecting your data, and if that's accurate to your data, even if you don't have a high quality GNSS, you can use that to adjust the visualization of your data and take away the inaccuracy of your viewport, because it doesn't have a high accuracy GNSS, away and bring you back down into the sub-meter, sub-foot accuracy range. And you communicate these so the field knows this, and you train this in the field so they know this and have that connected to your maps that you're using in the field. Think about it. Think about the concept. One of the early stories, this is pre-ZFocus, this is on an old one. We worked with an oil and gas company for quite a few years until they got bought. And they used augmented reality. So they go in the field. The field people do locates connected with their wand and their augmented reality, and then they'd use that to actually collect and improve GIS data. By the time they're done, after 2 years, using this as their method of collecting GIS data, all their data was sub-meter, all of it, through all of their different places. So you started having a new powerful tool because they were trained in field maps. They're trained in augmented reality, that they collected and helped you get your data to the new standards that you need. And of course, evaluate your accuracy needs. Have a realistic view of that. Understand what you really need so you can have a clear expectation, and you won't set expectations that won't connect with what your data quality is as it currently stands. I have found value in some very accurate and very inaccurate data, and so I know that you guys as well can. So hopefully that kind of gives you a sense of how we got here, what this idea is, kind of the road of kind of the longest standing AR play in the GIS world, and how we're and what we're kind of accomplishing, or what we think is the story for 2024, 2025. Um, and hopefully it was kind of interesting, a little bit at least. Uh, and so any questions? And I think I left some time for questions. We got, because I know that Jason was going to speak a bit at the end. So I think we should be pretty good.
Totally engaging. And I apologize. One of the challenges is, having an audience that you can see or hear and giving some feedback when you're trying to talk. So
Yeah.
I would encourage that anyone that's on the phone or on the video now to open up if they have questions so they can ask them verbally. Um, I just know that one thing I was thinking of, Brady, in the future, we're probably going to be saying, why was I driving blind for so long when I was out in the field?
Hmm.
Why would I go out in the field without having the full knowledge, or at least a good corporation of the knowledge that comes from the office that could be available through augmented reality? Um,
Yeah. And there's a big truth to that, because the reality is a lot of your field crew, I mean, they're good at their job, right? They buried that pipe, they buried that wire, they know where it is. But there's also, a lot of turnover happening in the age of what most of this has been done. Those guys are aging out. They're 60, 65. They're retiring. And the new
mhm.
crew didn't bury it. And the new crew is looking for technical advancements and things to help them do a better job, right? They're not afraid of pulling out their phone and kind of scanning the area to make sure they know what's going on, so that they know that, oh crap, there's a second, oh, I'm not supposed to use that word. Oh shoot, there's not there's a second there's a second pipe down there. I didn't even think about that. I about hit that, something like that. So
there's some things that you can only find in the field or easily describe once you're out in the field,
mhm,
um, that are difficult to be able to describe otherwise, without a sketch or without some sort of way of being able to track that configuration, like a workaround for a sewer
mhm,
connection, for example, especially
mhm,
if it's gravity fed, might be a triangular piece of infrastructure in order for it to all flow, for example. And
mhm.
um, how does one raise their hand on this? So Nate,
I was
Nate Johnson
gonna
has a question.
Sorry, no, I was actually like most of the technical of why your data doesn't line up was I've done plenty of locating and such, and I was like, yeah, that all makes sense. This is all right on. But then when you started talking about tying into existing, like even if you don't have a GNSS that is super accurate, you could have the data available from here's a building, there's a cell tower, there's something like that. So you
mhm,
could actually get quite a bit more accurate just based on a local
mhm.
reuse of the same data that you're already using, right?
Yeah, no, I mean, that's one of the powers you just have to think about, is that because there's different types of accuracy, right?
Right,
There
right,
is accuracy to the world, and then there's your data being accurate to itself. Like if you
right.
did a pretty good survey and that flagpole is actually correctly connected to all of your else data, if you can align the flagpole's data with the flagpole in the real world, all of a sudden all the rest of your
All
data
the rest
drags into
is
high.
good. And
Yeah.
and a lot of times just in virtual reality, your overlays are going to be distorted because, your ground is supposed to be here, but it's never there, right?
Yeah.
Like, so you have a distortion of, and I'm looking at
Yeah.
it at this angle instead of at this angle. So is that really where it appears on the screen, or do I need to stand on top
Mhm.
of it and look straight down? That
Mhm.
kind of stuff is
Yeah, and that's actually
pernicious.
beautiful. Yeah, it is. And that's actually why most of our customers, I call about 90, I don't know, higher than 95, in my opinion, percent of our customers use what I call paint the ground with elevation methods. Because
Hmm.
if you put in 3 dimensions, I mean, it's all 3 dimensions because that's the world's 3 dimensions, right? But if you put the third dimension, you drive that pipe underground, your eyes don't really know how to do that. It messes things up. And the only way to make it really look good, although I have a few ideas we're going to be rolling out in 2025, hopefully they're going to work. We'll see. But is covering up the world with complete virtual reality, which is not the point of augmented
Right,
reality. The augmented reality
right.
is to see the world.
But if you did like
And
a,
so,
a wireframe, like an
yeah,
invisible wireframe underneath the
yeah,
current
there's
structure, that'd be,
yeah, things like that you can do, but even then those get pushed to the surface. So
yeah,
most people, they want it like you paint. You paint the ground, it lays there on the ground, so it looks right, it moves right, it feels right to the eyes. And
right.
and so that's what people use. But yeah, no, it's I'm glad that that kind of clicked with you as that known, what we call known points.
Yeah, it's awesome.
Yeah, thanks, Nate.
I have a question. How can how could you use this platform with like search and rescue?
That's a great question. We actually laid out a pretty interesting story. So it's not quite search and rescue, but it was with wildfires here in Colorado. That's always a challenge for us. And simply giving people the ability to scan the horizon and know what direction the stash is of equipment, or the fire line is, or all of these types of different types of things. Um, gives situational awareness. I mean, that's really what it is in a search and rescue. Where did they report themselves? When you're on the ground, you're running up the side of a hill. I don't know how many of us do backwoods hiking, but we all know that you always have to be careful if you're in Colorado and you're walking on mountains, because you don't even notice and you've just curved around the edge of a hill and you're no longer walking north, you're walking ain't north. And when you're in trees, you can't see that. And so you can have something that always points to where the last reported place for the rescue could be incredibly powerful. and that's what augmented reality is. You just bring it up, you'd see the world, you'd see the thing, you'd see the path.
And
And so
are you thinking about using your platform in like data collection of like search and rescue drones, perhaps?
we would probably not do the collection in AR because it's pretty much a visualization. But yeah, I mean, it could be a full thing. So if the drone figures out where it is, connects it, collects that data through
Mm,
whatever type of data capture you're using on the drone, then visualizing it back out as actual feet on the ground start walking out there. That would be where it is. But we haven't. I mean, most of our play, like the market that we're pushing into, is more state and local government and energy districts. We've talked with search and rescue and the public safety, but we haven't really dove in there yet because I don't know the market real well personally. So
mm.
but yeah, if it's interesting to you, I'm more than happy to talk more about it.
Also, are you guys keeping your eye on the updates with meowography, and are you going to be implementing that possibly? I'm not sure how the data collection is going to be working with that, but it's been really
I
interesting to see what they can do with those.
yeah, I'm sorry, you said I didn't hear the first word. I apologize.
Meowography.
Oh,
That's where they're taking the muons to, map
yeah,
underground, unseen, blah blah blah.
yeah, no, yeah, no, I've been I yeah, we're watching it again. We're a visualization. So as that data comes up and seeing the value of that data, we're happy to visualize it. Um, haven't really ran into it yet from a practical standpoint of
Right.
data that exists that we're doing anything with. But of course, yeah. I mean, I'm a tech geek, so I love anything like that. So I
Yeah.
mean,
Yeah.
Brady, I had the question of the collection of photography in the field and how that could be added to help with some of these things. For example, we have construction managers that may be collecting spherical imagery
Mm,
for inspections and being able to present that information back at the ranch in the right orientation and placement in GIS, and how prior collections might reflect comparisons against current conditions in the field. Is
mhm.
that something that you've given some thought about?
S- So if I understand that correctly, it's kind of about like going into the field, getting some advanced imagery, and then bringing that back to the office and correctly placing the data into that imagery so you see an overlapping of the spherical imagery with the data. Is that what was asked? I just want to make sure I understand it.
That is right. Like
Okay,
if we
perfect.
had gone into
Yeah.
say a communications vault and taken a spherical
Mhm.
picture of the what's contained within it, then how could we represent that, and could that be represented in augmented reality? Um,
Absolutely. It I would argue that either be mixed or virtual reality at that point because you're no longer
right?
standing and not augmenting actual reality around you. But yeah, absolutely. In fact, an early system that we piloted for um actually vacation like hotel like location is laying data over video cameras. So you could like from a distance, you could be watching video cameras and have your data and your locations and your spots showing up accurately over that video feed. And it works in general in a lot of ways the same way as augmented reality because you just need to know the location of the viewpoint of the camera and what the focal point of the camera and how it sees the world and its perspective and all of those things that basically what type of lens you're looking through and then you can find a way to craft the data into that. So
Thank you. That really helps. Yeah, mixed reality might, yeah, or semi-transparency of imagery. I just
yeah,
couldn't think of how it would be
yeah,
both practical in the
mhm,
office and in
yeah,
the field to be able to use that information and yet not be
yeah,
overwhelmed by it or confused by it. So often
yeah,
in the office, we're looking at the photos that have been received, and we have to orient those photos to the direction that we're trying to figure out where the infrastructure is. And now, if we're looking at the
mhm,
spherical stuff, we're going to have to figure out, okay, where is it? Where is it coming from? Where is it going to? And how are we going to make sure that that information is available to someone who views it in context, even in the office, let alone in the field.
Yeah, no, definitely. It would be, yeah, honestly, the platform that we've built to translate GIS data into three-dimensional space could be used for that as well. So
That's good. That's good to hear. On the paint the ground stuff, I appreciated the fact that you had it raised over the grass line so you could see what was
yeah.
going on, even if you had visual obstructions on the ground. Um,
Mhm.
I thought that was pretty helpful. Yeah, it would be helpful to have depths and z values and all our data to begin with, and a lot of that doesn't happen but in attributes in GIS unless we've got a
Mhm.
collection in the field with z values to begin with. And I think that that would be most helpful for engineers, of course, when they have to have that information, or um, those that are trying to clear or cross utilities for construction purposes. Um, I think that's a challenge, a general challenge when you're talking about the accuracy, the positional accuracy of the X
Mhm.
and Y's.
Mhm.
Um, that's one thing. And yeah, I think the consumption of the data in the field particularly will help improve that positional accuracy a lot. And not only the positional accuracy, but the configuration accuracy of that. That line work isn't quite right. We've got this little wiggle that's supposed to be over here and that no one knew because it was but we know because we can see the divot in the ground where
Mhm.
the
Yeah.
line was buried. So gathering more information in the field will certainly be helpful to improving the accuracy of that
Mhm.
information. It's always
Mhm.
consumption in my mind that leads towards the greatest positional accuracy, but you also end up in a situation for a lot of municipalities and other infrastructure laden water telecommunications companies, et cetera, where we get to a generic level of high resolution positional accuracy information because of the frequency of use for so many different kinds of applications that it becomes almost
Mhm.
an expectation. Can we get it within 18 inches, the proverbial width of a backhoe, or within 6 inches,
Mhm.
um, so that we can be certain that that's where it should be painted for an 811 um,
Mhm.
marking. If it's above ground, yeah, you don't normally need that kind of accuracy because you can see it or reach it.
Mhm.
Maybe a meter is going to be just fine for those kind of situations. And then, yeah, what kind of phenomena are we talking about? Are we talking about infrastructure? Are we talking about, um, I don't want to say imaginary things, but um, a right of way or a property line has more accuracy often when it comes to knowing who has property rights. But other things like the center line of a roadway may be a little more abstract, or particularly the natural habitat of a uh, Preble's meadow jumping mouse, for example. That's a little more
Mhm.
abstract on where the beginning and the end of that
Yeah.
really is. And so there are some phenomena, especially natural phenomena, that are approximations of what's being represented on the ground, but not hard locates of infrastructure. And so being
Mhm.
able to recognize those differences is important. Yeah, edge of pavement or back of walk might be a lot more important than knowing how close you are to being the center line of the road. Center
Mhm.
line of the road is an imaginary thing somewhat, unless you're looking
Mhm.
at the crest of the road, and that's a different matter. But anyway,
Yeah. Yeah, no, but that's the thing, is that you have to think about your accuracy, and you can also think about where does value come in into the accuracy, because sometimes you just need like a situation like at the beginning of a locate, as you brought up. Doesn't really matter if it's accurate at all. They have to use the wands. It's kind of legal. I don't know a single group that's gonna, not use them. And so they see and they're like, okay, I've got three pipes. One takes a hard left. I've got to, locate all three. They have a sense of what they're going to go out there and do. Once they get a good starting point, they start doing it. At least they're not surprised by what they find. Because even in a locate, when you're out there with the wand, there's a ghosting of the signal. So say it takes off left, right? And you kept on going straight. You can go 10, 15 feet before you realize the signal is completely down, depending on the situations. And then you can spend 45 minutes trying to figure out what happened, right? Situational awareness. 2 meter, 3 meter accuracy should have been good enough to help that situation, right? So it gives you a sense of what is needed for the situation that I'm helping, and how do I get there? So
That really does help. Yeah. Yeah. I mean, in our mind, sometimes we think about infrastructure and how, if we just knew more precisely where it was, then we could spend less time in the field trying to find it.
But
Or
I
or
would
pretty
trying
much,
to report it. Yeah.
I
yeah.
would argue that if you know where it is relational to other things in the field,
Mhm.
it is 1,000 times more helpful than knowing like following the wand out. Yes, of course you have to do that. You need depths for accuracy and coordination reasons, but yeah, you could be walking along and the signal could go left and you're tracing out telecom and suddenly you're tracing out a gas line.
Mhm.
It happens all the time, like
Mhm.
all the time. So if you knew that, hey, there's supposed to be two telecom lines going this way and you got a weird signal, then you would know I probably should go
Mhm.
left
Yeah,
or
no,
maybe I shouldn't go straight.
yeah, no, it helps. And then also just liability, if you're, depending on if
Mhm.
that's something that you haven't outsourced or something, a picture that shows all your data,
Mhm.
date stamped, time stamped, and your paint and your flags, and you're like, yeah, I did it. I did it at the right time. I was within the metrics. So when
Yeah.
the finger pointing happens because somebody hit something, can be pretty handy. So
And the finger pointing will happen.
it always does.
I
Always
hope not
does.
too too much. Hope not too much legally, especially. Um, Brady, thank you for presenting today, and thanks for everyone
Yeah.
participating in the question and answers. I'm going to turn over to Ron and share some slides for his um, presentation, if I can get it to share appropriately. Um, Take it away, Ron.
Okay, so please join GIS Colorado. We have our quarterly meetings. We have a very professional networking network of 1,000 people in our listserv where we share lots of information. We give out scholarships once a year. We're going to be launching that soon. The two quarterlies we do have coming up are the first one is going to be in February of next year on the 27th and the 28th. We have the winter meetup, and that's going to take place at Denver Water. And then we also have our La Junta coming up in the winter. And next slide. So regional events taking place. We have the Geography Awareness Week going on November 19th, and at CSU they're having their Bringing It Back to Earth themed event at this Geospatial Centroid. We have a few events right now for a GIS Day taking place on Wednesday, November 20th. We have one in Greeley with the UNC. We have one at Aspen with the City Hall. We have the OIT team doing their event at the Castle Rock Library and in Longmont Library. And then once again, the CSU Center will be on the 21st of November as well. And there's a current mapping hour being planned with GIS Colorado that is going to take place on November 20th. So keep your eyes out for those details coming to the listserv soon. And for the Geo-Ruckus next month, we'll have Atlas Geo doing some LEGO topographic mapping, and he'll be presenting on November 7th. And once again, thank you to all our sponsors here.
And I think that's it for the slides that we
Yeah.
have. Yeah.
Thank you to everybody for joining us. It's been a great little event, and look forward to seeing you at the next event.
Very much. Appreciate everyone's participation today. And yeah, thanks for coming. The recording should be available sometime next week. Is that right?
Mhm.
Okay.
It will be soon. Yeah. Cool. Well, thank you, everybody.
Thanks, Ron. Thanks, Brady Hustad especially, and thanks for everyone online.
Thanks, guys.
Boy.
Thanks.
Thanks.